cutting the 7-month journey to Mars in half. What if I told you that a new type of rocket engine, powered by nuclear energy, could make this possible? With space agencies and private companies pushing for human missions to Mars, the question remains, is nuclear propulsion the key to deep space travel? Or is it too risky? Let's break it down. Space travel today is incredibly slow. Even with the best rockets, a trip to Mars takes about 7 months. But what if we had a faster, more efficient propulsion system? One that could cut travel time by 50%, use less fuel than traditional rockets, open the doors to interplanetary travel. This isn't science fiction. NASA and DARPA are already working on nuclear-powered rockets. But how do they work, and are they safe? The problem with current rockets. Chemical rockets, like SpaceX's Starship, burn fuel rapidly, making them powerful but inefficient for long space travel. The farther we go, the more fuel we need, which means heavier rockets and longer trips. Radiation exposure in deep space is a major health risk for astronauts. The longer the journey, the higher the risk. If we want to send humans to Mars and beyond, we need a faster, more fuel-efficient solution. How do nuclear rockets work? There are 2 main types of nuclear propulsion. 1. Nuclear thermal propulsion, NTP, works by heating liquid hydrogen using a nuclear reactor. The hot hydrogen expands and shoots out the back, creating thrust, 2x more efficient than chemical rockets. NASA's DRACO project is working on an NTP system for Mars missions. 2. Nuclear electric propulsion, NEP, uses a nuclear reactor to generate electricity, which powers an ion thruster. Much more efficient, but produces less thrust, making it better for deep space travel rather than fast launches. Which one is better for Mars? NASA believes NTP is the best option for Mars missions since it provides more thrust and reduces travel time to just 3 to 4 months. Will nuclear rockets actually work? NASA and DARPA's DRACO project aims to test nuclear thermal propulsion by 2027, could pave the way for faster crewed missions to Mars by the 2030s. Other countries are interested too. China is developing its own nuclear-powered space program. Russia has tested nuclear-powered space tech since the 1960s. Potential risks and challenges. Radiation concerns. Could the reactor leak radiation into space? Launch risks. Nuclear rockets need extra safety precautions on Earth. High development costs. Building and testing nuclear rockets is expensive. But if successful, nuclear propulsion could change space travel forever. What this means for the future, faster trips to Mars, 3 to 4 months instead of 7. More efficient, long-term space exploration, possible missions to Jupiter, Saturn, and beyond. The race for nuclear propulsion is on, and the next decade could define the future of space travel. What do you think? Are nuclear rockets the key to Mars travel?